First, return to the two-blade wind energy technology and then reach out to the oceans with floating wind turbines to exploit the very best wind conditions. And don't forget, in the end, to convert the electric output into hydrogen molecules, because that's the best way to store and transfer massive amounts of wind power. May we present Seawind.
When these men start to talk about their wind energy innovations, even online, it's impossible to only use words.
And that enables us to have a much simpler turbine, much less pieces, much less failure sources.
As for the rotor dynamics, Seawind embraces a certain approach already in use in the first generation helicopter design.
What is called the teetering hinge. It's a seesaw hinge. It unites the blades and gives them an additional degree of freedom to rotate and at the same time do this. And he's inserted that in the helicopter industry, which then became standard. So if you don't insert this teetering hinge, you will have a problem.
Moreover, Seawind falls back on the two blades technology, as once introduced by NASA.
NASA made the comparison between all kinds of configurations and found out that the best configuration is the two-bladed configuration. To the same result came one of your co-nationals, Henk Lachawai, as you say. And he built a huge number of two-bladed wind turbines, small, but you can still see them today in the Netherlands, in Germany, here and there.
But the development stopped, partly because people didn't find them attractive.
It was aesthetics, yes, for sure. Yes, for sure. But offshore, there is no issue.
Offshore wind is ready to move to the deeper seas and oceans, so why not push on the technology restart button?
So we go into deeper waters. Minimum water depth we need is 50 meters. So we start where the three-bladed pile-driven, let me say, technologies end. There we start. So they go up to 50 meters. That's our starting point. And then we are going up to 3,000 meters of water depth by a floating foundation which is made of concrete. It's a huge piece, very heavy, but it absorbs the noise, as said. It is very economic to make. Concrete is more economic to make than steel. Concrete has less CO2 content than steel. So in terms of economic efficiency, we are about 1/3, or 25 to 30% more economically efficient, means more economic than a three-blader, because of all these, of the sum of these advantages deriving from the teetering hinge.
To make it complete, the conversion to hydrogen would even give wings to the Seawind innovations.
For sure, for sure. That is the next dimension. Now, I was saying this more than 20 years ago, which we have used these 20 years because we are ready today. So we are ready now to produce the hydrogen on those floating platforms. And we are working with leading American group in this sector, National Oil Well Varco, for bringing the hydrogen by a flexible pipe to shore and then to the distribution. So we have an entire concept how to produce the hydrogen offshore and bringing via these flexible pipes at very high pressure, 500 bar, at very high pressure, so you transport a huge amount of hydrogen.
A silent revolution is taking place, floating offshore wind in combination with hydrogen production.
Are you able to make a business case?
Now, yes. In these days, yes. But it took us a long time.
The wind has turned already. I mean, 2-3 years ago, nobody was talking about floating wind. Now we talk about the Green Gulf when we refer to Ireland and UK. We can also produce electricity cheaper than fossil, which is also new, because up to 3 years ago it was like borderline, and even today all competitors are struggling not to produce without subsidies. We can go without subsidies, and once you produce lower than fossil and lower than nuclear, there is no way back.
Next steps for Seawind are developing floating wind parks off the coast near Japan, Italy and Portugal.
So we are very optimistic that this will fly, and it will fly very, very high.
Thanks for watching newenergyforeurope.com.